All right. Welcome everybody to class. Who remembers what happens on Thursday? What I'm going to ask you for?
Data sets.
Yes, what data set you've chosen. I'm going to pass the sheet around the room. Maybe we'll do it electronically. I haven't figured that out yet. But you're going to write down what data set you've chosen for your semester-long project. Is there anybody who has no ideas yet? Good. You all have ideas. Have most of you identified a place to actually download this or get this or a way to get this? Do you have questions right now? No? All right. I look forward to hearing that. And once you gather the data, then you're going to work as the semester goes on cleaning the data, exploring it, which usually just means plotting it somehow so you can see it. So many things you think are working fine until you can see the data. Seeing the data is so important. And then modeling the data and then interpreting it. So I don't really put that as the last step. It really should be part of this whole thing. But modeling the data, modeling is a funny word. To model something. If you're to define this in a short sentence as a verb, to model something in machine learning means what? I want to see a couple hands.
Visualizing.
Okay, that's one idea. What else? Model something.
Isn't it just applying it?
Applying it is that's another good word. What else? What else is involved?
Can I hear more about the graphing?
Graphing, that's kind of like visualizing. Yeah, meaning and understanding. So contextualizing, like what does this mean? What does that mean? A model of something is something that acts like the thing you're modeling, right? If you have a model of a physics engine as a model, how many of you play video games? In those video games, they use physics engines. And the physics engine determines, when something falls, how fast does it fall? When it crashes, does it explode? Or if it's water, does it flow everywhere? If you're a character in it, when you run, what's the gravity you feel? All those things are part of the physics engine. They're a model of physics. So a model of something is something that's going to act the way the real thing acts. It's going to be similar to it. So let's say you have a model of English. ChatGPT is a model of English, right? It's a model of maybe people who respond to each other in text. That's what they've tried to learn from. And to learn, a data set they use? Like all of the internet, they tried anyway. And they had things like GitHub. They had all of the open projects on GitHub. And they have a human in the loop step afterwards that tries to pick good outputs so they can separately have a model that tries to hone it and perfect it. But think about that. A model is something that acts like the thing you're modeling. So ChatGPT, it's going to act like a human that's helpful and chatting with you. So that when you ask it a question, it answers you similar to how that human would react. When you drop something in a physics engine, it's going to fall or try to make it fall in the way that it would in real life, under real physics. All right, everyone get your laptops open and go to a collab. And just look up when you're ready. All right. Before you start coding this stuff in there, you see this folder on the left? I want you to click that. And what you'll see is this is how you can access other files that are uploaded into your collab right now, or you can connect your Google Drive or other things. Today, we're just going to look at the folder sample data that should come along with your collab. Does everybody see the sample data folder? Now, if you click that arrow, you'll see a number of these. And we're just going to look at the California Housing Test CSV. And we're going to learn to read a file.
Oh, just click it out.
So a lot of the samples you will see online use something called Pandas. Pandas has its own CSV reader. We're going to use the standard Python CSV reader today. Now, Pandas is just a way to load in a bunch of data like the data you see here and do things with it. It turns out it's actually really bad with memory, and it's not good with compute either. So there's something that acts a lot like Pandas, just like it, but it does it much more efficiently. And if you really want to do something like Pandas, I'd actually suggest you use Polars instead. Polars is basically Pandas, but written with an efficient backend, written to be parallelized, for instance. It's just faster and more efficient. But today we're going to do neither of these. We're just going to straight up read in this file. So you can just copy exactly what I have here. And then run it and see if you get what I got. All right, raise your hand if you've got the same output. For those of you who got different output, what did you get? Or did you get an error?
Oh. Then that's the MC.
Oh, there's no. The CSV dot reader. More than middle history, private reader. Yeah. Anybody else?
Here's a 6-space tab.
All right. What kind of thing is row? R-O-W, that, or row in reader, what is each instance row?
I'd imagine it's a property of the file object that refers to each complete line.
It does refer to each complete line, yes. But what is the variable type? You get one, yeah, you take each line at a time. But when you have that one line, what is it?
Just string.
Nope.
So an array of strings?
Yes. Or it could be an array of other things. And the way we can prove that, find that out, we can just do print type row. Then I can just exit. Ah, it didn't exit. Huh. It's a list. That's why we use join right here. Now, join acts weirdly in Python. Yes.
So. Where are those lists? Like, stuff these lists.
Yeah, so join is a little bit weird in Python. Just to tell you how join has worked sometimes in other languages, you would typically think of join as a function outside the thing that works on the things. You might think of join in, remember, other languages as doing something like and turning that into this. That might be how you think of join, but that's not how it works in Python. In Python, join is a function of a string, the delimiter string. And this is strange. I know, took me a while to actually get used to it. But if you see that dot there, whenever you have a function name after a dot, that means it is a method of that object. Who here has heard of object-oriented programming? Okay, so object oriented programming. OOP. It's just a way of thinking. Every language has one or two ways you can think as you program in that language. In object-oriented programming is you think about the object first, then the things that can do. Like if I had a method bounce, I would expect basketball to have that method. Maybe even economies can bounce. We talk about the economy bouncing back. Anything that can bounce could have the bounce method. Anything that can turn green could have the turn green method. Whatever it is you're imagining, you have some object, and let's say your object is some variable or some object called basketball, and it has an object bounce. And functions have parentheses after them. That's where you would pass the arguments if there be any. And if there's no arguments, then it's just that. Now, a lot of things you'll find in Python and other computing languages, there's always something behind the scenes, always something else behind what you're actually writing. Sometimes it's just a compiled version that's in a computer language you'll never understand. Or sometimes it is something understandable. And this is one of those times. So basketball.bounce is just we have some object called basketball, and it's got a method. And if you were looking in the code for basketball, an object in Python is called a class. So you would have some class. And let's say we call it basketball. Now, when you actually define an object in Python, it's good to start it out with a capital letter. That's the standard. And if this is a version of another object, we call that subclassing. Now, I'm throwing a lot of concepts at you, so feel free to just like ignore it and stow it away for later. But OOP is something you should look up and watch a couple of videos on. So let's say basketball is a subclass of ball. It's a type of ball. Well, from ball, it will inherit a bunch of other things. But let's say we have to, in here, there might be some constructor, the way to define how you make the object originally, stuff like that. But somewhere in here, there will be def bounce. Now, the weird thing is, inside here, you have to tell it that bounce expects to know about the object itself. It's not automatic. And the way you do that is with the special word self. So now you have the code for making actually go up and down, or down and up. But def bounce, and the argument you pass it is itself. It's a weird way of writing, but this is how we do it. And that is what's actually going on here. So where it says no arguments, there's actually one argument implied, the object basketball itself. When basketball.bounce parentheses is called, this function right here is the one that's actually being called. And then maybe in here, there's some code for engaging with the physics engine. Make sense? So in this example, what is the object? There's no variable name there. What is the thing before the dot?
The string.
The string itself. And what you find is that every string in Python, I actually don't know where it's defined, somewhere in the guts of Python, there will be the code or the object methods for strings, and it applies to any string. And there will be somewhere in there join. But join you have to start it off with self, so it knows about itself. But then it also takes a list. Let's call it X. And then what it does is, remember, itself is a string. It's going to use itself as the delimiter. And each element of X is going to become a thing in that longer string. So let's say our list, I'm going to change the code back. There we go. Okay. Okay, let's say that's our list. The string is comma space. That's literally all it is. What this means is it's going to take the things in our list, it's going to put them all together to one string. Okay, what did I forget? I can't hear you.
Comments?
Yes. The string dot comma space is in between each one. That is what join does. Now, if I had, written Python from the scratch, I would have done that one thing differently. But trust me, most of the things Python does are actually the intuitive way. I really like the way Python does most things. That is one exception. So that is what's happening. And that means that row thing is a list and you have total control over it. You can, let's do something like printing out the number of each row. Does anyone remember what special word we used last time to get the number of each thing? Yes. All right, so everybody enumerate the rows and let's print that out at the beginning. And if you want to follow along, you can. If you think you can do it on your own, do it on your own.
It's gonna be Jason. It's gonna be-
That was an accident. Oh, it's caps lock is on, that's why. Everybody get the same result? Now, let's make it Stop at line 10.
Is there a reason you have the lines staggered other than just organization?
Yes, they have to be staggered for the way Python works. Now, I staggered them with 4 spaces each, but Python also will work if you use 2 spaces, but you should try to be consistent. As you play with Google Colab, you'll see the default is 2 spaces, and that's fine too. But this if statement, basically, everything inside the if statement is what's staggered underneath it. As soon as you stop staggering, it assumes that if statement's over. Same thing for defining the for loop. Everything not staggered is not part of the for loop. Once you unstagger, you're out of the for loop. And the same thing for the with open. So that with open statement, what that means is that we're going to open up a file handle. This is the way the computers actually read files. And we're going to call it CSV file. Only inside the staggered area is that a thing. If you were to unstagger, CSV file would no longer be a thing you could use. Now, sometimes that system breaks down a little bit, but for the most part, that's what they're trying to do. Some languages, instead of using staggering, they'll have, you know, an open curly brace and a closing curly brace, and then it's easy to tell everything inside of here is part of it, but not Python. All right, can everybody do this? Print out just 10 lines. All right. Now we're going to do something similar for each element in each row. Actually, we'll do this. Out of here. All right, does everybody see what I'm doing here? We're going to only work on rows 1 to 10. That means I is less than 11. And then we're going to enumerate things in each row from 0 to whatever they are. We'll find out. And we're going to print that thing. And then you get a repeating 0 through 8 again and again. That means there are 9 columns. So once you're done with that, tell me what's weird about the data. Something looks really, really off to me.
The column labels are being listed as.
Yeah, that's fine. But look at the column labels and look at the data values we're getting. Does anything look off to you guys? Because it really looks off to me. Yeah. Where is this place? Are these mansions like beyond Bill Gates? Bill Gates couldn't afford this house. What is this? Short answer is, I don't know. This is the standard little data set file that Google gives us for free to use. Why would they give something that has so obviously has wacko values in it? And I can't tell you.
There's like total room for a county or something.
Maybe California housing test. I mean, the file itself doesn't come along with much explanation except the titles. These strings at the top of the columns. Median house value, median income. 7 and 8.
I don't have anything like in R where you can do like question marks and then the data set and then it gives you any.
Not inherent. However, some Python data sets do have stuff that comes along with them. But I don't think this is one of them. This is literally just a CSV file.
It's for the districts.
You found out? Did you look it up? Tell us more.
Oh, I didn't read it yet.
Oh,
Yeah. This one is from GitHub, so I don't know if that's the same one that you're using. But it says it's for the districts. For this specific.
does that mean total rooms in the district? We don't know, do we? All right, so I did this to show you real time. There are always going to be issues. No matter how good your data, you think your data set is, there's going to be issues. You're going to have to clean it. It's going to have weird things, and you have to look into the history of it, where did it come from. Maybe somebody just made a mistake and forgot a column title, and that's something totally different, or they just mixed it up. Any other thoughts or questions
About the data setters.
in general?
When you import CSV, is that giving you like a bunch of, is that giving Python a bunch of information on how to read CSV files? Because it seems like it was way easier than saying like, oh, break into an array when you see a comma and stuff.
Yeah.
Like, oh, okay, so it just helps you once you say import CSV, it just does it.
Well, early on, a lot of people started to write all these different modules that help you do everything in Python. But if Python loaded every module in the world every time you ran it, it would be slow to load.
It's like
So-
a comma.
What's that?
It's like
Funding,
pound.
exactly. It's like pound include. And it's like you already have it on your disk somewhere, but it doesn't use it unless you tell it to use it. And the CSV, in this case, CSV.reader, there's another one called .writer that can do the same thing, but output, obviously. And a lot of packages are like this. Now, that dot, when you're using a package or a library that someone else made, the dot will often mean there's some object and you're using some function inside that object. But it can also mean something else. Let's say you're importing CSV. It could be that there's a CSV module somewhere, and underneath it, there is a reader object in literally a folder below. So sometimes when you import something, the dot can also mean look in the folder below. So you're going to come across difficulties and moments of confusion with the Python module loading system. It's good in some ways. I like it. We don't have to do all the includes and header files that you have to do with C or C++, but it will sometimes confuse you. So don't be afraid to ask questions. Any other questions? All right. Is everybody on Discord? No, you need to get on Discord because your TA has been talking to you guys on Discord. Your first, go ahead.
I emailed you about it and I would never be back from the TA link.
Email again.
Okay.
Sorry. Yeah, email me and him at the same time.
Okay,
You can do it right now.
sure.
So he basically said that your first assignment is already there. It's in Zybooks. You can get to it. It's the challenge at the end of chapter 1. And we're almost done with chapter 1. What's that?
There's also confusion grading.
Yes. All right. Let's continue. This is another paradigm. Like I talked about object-oriented programming. Well, this is a paradigm for data. And it's called CQRS. Who here has a fitness tracker or a watch that can do that kind of stuff? 1, 2, 3, 4, 5, 6. Not too many of you. I don't. I've got the old analog kind. Literally doesn't even have batteries. But a lot of people love fitness trackers. Think about all of the Apple Watch users out there in the world and all of their data, heart rate, maybe, I don't know if it can do blood pressure, but it can sense some things like blood oxygenation level, I think. It's recording other things about the heart rate, like heart rate variability. It might be trying to measure your VO2 max. There's a lot of things about your health that it can measure. Let's pretend you have a whole lot of people using their watches at the same time. They're all exercising, and maybe it's a spike in the amount of data coming in. Apple doesn't want to drop any of those data, any of those bits or bytes. It wants to make sure they get stored. So you have to have a fast way to take in the data and write it through a database. And you might call that the command side. Sometimes they call it segregation or separation. You want to separate the command and the query. So the command side in this scenario that I'm talking to you about is merely taking this data and store it somewhere. It has to be highly efficient, and there have to be listeners running. A listener is a program that's literally listening on a port for a query to come in. And if you have 10 million people trying to send a query or try to send a command to save some piece of data all to the same computer, to the same port, even if it doesn't crash, there's no way they will all get through. So out there on the magical interwebs, they do load balancing. Who here has heard of load balancing? Load balancing is when you have tons of queries or commands coming into a port and you separate them into a bunch of different separate computers. And you do it in real time. And if there's not enough computers to handle it, we spin more computers up, start more computers, so that there is enough. Netflix is doing this all day long. Think about the amount of data that they have to not only store, but to supply to you. Everything in their library at any point, all the time, 24/7. And sometimes they have very few users, maybe 2 or 3 in the morning in this time zone anyway. And then other times it'll spike up and they have to be ready for both. So when you're using your Apple Watch, let's say, a little piece of data about your heart rate goes through your phone to the cellular networks. It comes into some computer, some port somewhere, and I will say it goes to the command side there. In the sense here, the UI just represents your watch. That's your interface to it. Goes into the command side, and it goes into a write database. Oftentimes, it's writing in JSON. If you actually download your health files from your Apple Watch, you will usually get a JSON file. Who here has seen JSON files before? All right. So a JSON file can look like this. I know it's a little small. This is just some example glossary stored in JSON. And again, you have the indents here, indenting, like the staggering. But here, the stagger is not necessary. It's done just for readability. You have a glossary, you have a list of entries, you got some term, an acronym, an abbreviation, and there's really only one entry here. It's just meant to be a simple example of what JSON is. And JSON is spelled JSON, and it stands for something, a serialized object, but don't worry about that too much. But you will probably use a lot of JSON. I like JSON better than CSV. There's a lot of CSVs out there, but that's kind of an older way of thinking. JSON is the newer way. So back to here. Your Apple Watch just created a JSON file, and it's going over the cellular networks, then over the internet to some fast write database, which sometimes is just a disk space. And for applications that I've worked on, we use S3. So S3 is basically Amazon's disks that you can use to save things on. It's super cheap and they're never going to run out. And you don't have to worry about connecting to one specific computer with that disk. It's a virtual disk. And if you have one person or 10 million people write to it, as long as you have everything set up with Amazon, it can handle that. It can handle all of that. It's never going to say, sorry, disconnection or out of memory. It's not going to say that. It's just going to take it all in. That's the fast write database. And this is very important when you have huge amounts of data or huge numbers of people that are interacting. Separately, we have a read database. Now, what we haven't been able to do, at least not cheaply yet, is read and write to the same database super fast and super, consistent. So there's a separate database that's just for reading. So whenever you have a query about the past, or whenever an Apple user says, what was my heart rate plot yesterday? That goes to the read database. And the read database is just like the write database in that it can take millions of connections. It can take all those connections and give you an answer. But it's not up to the minute or up to the second. It's the answer from the last time it was updated from the write database. Now remember, the way the write database can take all those inputs is that there's more than one. There's tons of them. They're all spun up and listed. Now, when they get that new data, eventually they're able to incorporate that into the read database. Once they do that, the system is considered consistent. Same data everywhere. Self-consistent. It is not always consistent, but it is what we call eventually consistent. And this is the way things have to work pretty much in the real world when you have truly big data. Millions of people or millions of things, millions or billions of whatever. CQRS is the typical way it's done now. Any questions? All right. Yes?
Sorry, right here. So when you're uploading images to an S3 database, would CQRS be kind of the way you kind of look, like how you kind of structure?
So
Like what
that's a
you're
good,
following,
that's a good example. Let's say you have a bunch of people uploading images to an S3 folder.
Right.
So you have a bunch of people out here and they're using their phone and some image is going in here. And there's tons of images already in there. Now, the idea is how do people actually take advantage of all these saved images? Well, one way is there has to be a searchability. Are you searching for the newest ones? Are you searching for the ones that have certain things in them, certain tags? So maybe you have, let's say, some search function. But this search function, in order to answer the query that some other person has when they ask it something, it has to know what's in here. And it can't know about the one that was just uploaded right now. So maybe what it does is it reads through them all once an hour. Or if you can do faster, maybe once a minute. Or some people do just once a day. And as it reads through there, it rebuilds its internal index of what's in there. That's one way this could work out. Another way people do this is whatever you're uploading in here, there's a second process that reads this into some other totally separate place where the data is more organized. And then when someone else needs something, they go to the very organized location. And you can write your app so that it does all of this automatically, no one even knows. Okay. Let's consider a different kind of scenario. Each of these is an ATM. You don't want your ATMs to follow the CPRS model. Even though you do want to do that for big data, you don't want to do that for ATMs. Why?
Is it real time?
Has to be real time. CQRS, the read database, is eventually consistent, but it's not up to the minute, right? So what if this is where you know how much money every person has in their account? And up here, is new events, withdrawals or deposits. If those two aren't perfectly in lockstep, what could you do? Let's say you gave your brother and your sister each access to your bank account, and they each have their own card. What could all three of you do together?
Spend the bank's money in a way when you spent all yours and hasn't updated.
Yeah, like let's say you know you have exactly $1,000 in your account. Well, each of you could go to a separate ATM around town and you could withdraw $1,000. If you do it at the same second, the system doesn't know, right? The system goes to the read database. How much money is in this account? $1,000. Okay, here you go. And it'll say that same thing to all three of you. That's a problem. And then you just go to Mexico forever. With only $3,000, yeah. Yeah, you won't be able to survive too long. So how do we fix that? Do we just shorten the time? Well, yeah, go ahead.
Maybe both, you only have one database, both three.
Yes, that's one way to do it. But there's a problem there too. Because if you only have one database, what if you get 10 million people going to your bank machines that day? Some of them won't get access to the database, right? That means you will lose on availability. Well, if you want to make sure it's always available all the time, then you can have multiple databases, but they all have to stay in sync before anything is done. So you have to have what's called a transaction. And a transaction has to go completely through or not at all. So let's say you want to take out $1,000. Well, you want it to always be available, so you have multiple instances of your database running, multiple servers with the same database. And you start your transaction, you say, I want to take out $1,000. Well, you contact one of the databases and say you want to do that. That database has to confirm with all the other databases that are part of the cluster, telling them, don't do anything for this account. I'm the only one doing this account. Or I'm doing this transaction, and this transaction has an ID. It is this. And I'm not going to complete it until I get confirmation of consistency from the other databases that are running the same database, the other computers. So let's say we do that, okay? If we make sure that all our servers are all consistent, then we have consistency. That means any ATM in the network, whoever actually hits the button first to withdraw, they're the only one that's going to get it. That means they all have to be able to communicate at all times to everybody, right? They all have to be in communication. But what happens if there is a partition, we call it? Let's say the internet goes down for this guy and he is cut off. What should happen here? If you were the bank, and it is your responsibility to write the software, what would you do? What would you do? What would your trick do? What happens to him? Does he get his money or does he get an error message? What did the error say? What's that?
You didn't give me one.
You didn't give me money. Okay, who would make the same choice? Error message. Who would say just give them the money and trust them? So when there is a partition, we have to make a choice. We actually call this partition resistance. Or reliability. So when there's a partition, you cannot have availability or you cannot have consistency. When there's no partition, then you can have both of those. But this is called the CAP theorem, CAP. You can't have all three perfectly. Anyone heard of a dilemma before? This is a trilemma. And trilemmas come up a lot in theory of computation, for instance. But this is an important one having to do with data. So if you're doing big data, sure, do this. But if you're doing something that needs consistency, like the amount of money in a bank account, you need to be aware of the CAP theorem. And it's because of situations like this that they came up with this concept. ACID compliant databases. Atomic means it cannot be split, which is ironic because we can split atoms, right? I don't know why they use that. But when something is atomic, cannot be split, and it refers to the transaction, whether withdrawing money or depositing money in that case, or any other transaction. If you need something like the money in a bank account, if it's that important that it be consistent, you need ACID compliant database. And you can be running on multiple servers. But it just means that when you start a transaction, it has to communicate with all the other servers and make sure everybody's on board before it says, yep, transaction's been complete. So either the whole transaction goes through or nothing. That is what it means to be atomic and consistent. We already talked about that, where every node on the database cluster all has the same data, the same truths. They all agree. Every transaction is independent. It doesn't depend on some other transaction. It is its own thing. And the database cluster views it as its own thing. And then durable. So let's say that if you lose power halfway through a transaction, the previous state should still be there. And that half-done transaction can be ignored and has to be started over. But the whole thing is durable. Durable to, all the things that can upset a transaction, be it a partition or loss of power. Any questions? All right. Typical CSV file, we looked at that. Typical JSON file, we looked at that. Now here's my least favorite, XML. I do not like XML. It was a standard for a long time to transmit the kind of things we use JSON for now. It looks like it's just the same as JSON, right? But it had something I find very annoying. Look at this, you'll have some tag, and inside that tag, there can be subtags or attributes of the tag. But also, everything that's staggered in is kind of like a subtag. So which one's the subtag? The one that's staggered or the one that's listed on the same line? These are typically called attributes. And sometimes the attributes have values, sometimes they don't. It might be. No, I don't think it is. No, I think it's just blase XML. That's meant to be the same exact information as in the JSON file. Anyway, XML is ugly. I hate it. Should try to avoid it if you can. Other sources of data obviously are spreadsheets, which could be as a CSV or an Excel file or a Google Sheets file or an Open Office file. There's a lot of different formats. Those are the most common. I found that in the past, Excel files will open easily within Google Docs. Sometimes. They used to work more often, actually. In fact, just as an example, the class list for this class that they gave to me as a professor, it's an Excel file that will not open for some reason in Google Sheets. I had to literally cut and paste it myself. PDFs are really problematic sometimes. PDF has to be read by a PDF reader. And PDF means portable document format, and it comes from a company called Adobe. Have any of you used Adobe products? They invented Photoshop. Also, they were originally, I think, known for typesetting. But a PDF file, weird things can happen. Like I've seen a PDF file have some data, like maybe it's on some years, 2010, 2011, 2012, 2013, and the Feb, March, and let's say you have some values in here. You trust in a PDF reader to read this file and turn it into actual text that you can use. Let's say you do that. I've seen it screw up things like this, and maybe it comes out as like, I mean, it can be all over the place. I've seen it just totally get confused. Sometimes it has to do with weirdly defined columns or how they created the PDF. Also, sometimes I'll be looking at a PDF and it's not actual text, it's an image of text. So maybe this is just an image that was literally copied and pasted pixel by pixel from something else, but it's not text or numbers. So PDFs can be problematic, but there are a couple of Python packages that can read PDFs, and they work sometimes. PDF Reader, PDF Miner, MINER. That might be the most stable one. I've used different ones over the years, and some of them have actually gone out of usage. So if you have to do PDFs, see how they come out in Python. You may change your mind. Databases, well, that's simple. It's structured data. You make a query, you get a result, and you probably store that result as a spreadsheet or CSV, maybe JSON. And then emails, well, depends how you get them. Some people do projects with emails. Try to get it as structured text, where you have the subject and the to and the from and the body all separately. When you actually send an email, there is an email protocol Does anyone know what that protocol is called? There are a couple different ones that have been popular. IMAP is more popular. The original one is called POP3, or one of the older ones. And this is the actual protocol that email servers use to talk to each other. And when they talk to each other, all the data is structured. Who it's from and who it's to is separate from the subject, separate from the body, separate from the attachments. All right. Has anyone ever seen NaN? What does it mean?
No.
Not a number. What a weird thing to throw in there. Not a number. Why not just, I don't know, throw some other thing or a null or something? But it's usually the system trying to tell you it tried to calculate a number and failed. What's the typical situation where you're going to fail when you try to make a number with a program?
String.
If it's a string instead, no, sometimes it'll print that all the way, or it might try to convert and have some other error. But usually people end up with these if they're trying, yeah? Yes. And like, let's say you have a whole bunch of values for, and these are penguin attributes. So you have these different kinds of penguins on the left, and this one is flipper length in millimeters. So for the Adelaide penguins, I think they just didn't have data. So when you are trying to get the average of something, you add up all the values that you have and then divide by the number of values that you found. So if you have 5 values, maybe it's 2, 3, 3.2, 5, 2. So you have these values 1, 2, 3, 4, 5. You would add them up and then divide by 5. But if you happen to not have data, you have nothing, you add it up and you get 0 and you divide by 0. Now, even though 0 divided by 0, you can kind of come up with something, but numerically, this is not defined. And that's a long talk. You can go down a deep dive in your own, what it means to be not defined. It's actually a very deep topic, but you will typically get an NaN in Python if you try to divide by 0, or if you let pandas do it for you, or if you let some other package do it for you. It'll complain one way or the other, and then you get these. So what are some strategies for dealing with that? How do you fix this if you just don't have the data? You can't go back and measure that penguin. It's too expensive to get to Antarctica. The whole data set? Or that row? That row, that's one way to do it. Yeah. What else?
When you're dealing with that specific attribute, you can just not include that single data point. Like,
Mhm.
I don't know about Python, but in C++, there's dot is NaN.
Yep. There is something like that in Python as well. And a lot of that stuff lives in the math package. So you do import math, and then you could do math is NaN. And then put the thing in there. And it'll give you a true or false, I believe. You can also impute. This is not perfect, but this is something a lot of people do. Impute. Anyone know what that means? We would just take the average of all the values that we do have in that column, just give it that value. And what it does is it's gonna throw you off a little bit, but hopefully it throws you off a tiny amount. And you're getting more benefit from getting to keep this number and this number and this number. There's no exact right answer here. You do what you do, and then you judge how well you did at the end. How accurate is your model? Does your model act like the real thing? If you have a model of all penguins, and then you interact with your model to see how good it is, what you can do is you can find a new penguin somewhere and see, okay, what species? Okay, let's say it's Gentoo. Then, if you measure the bill length, and that lets your model predict the flipper length, just from knowing the species, the bill length, then you have a good model. If your model has predictive power, if it acts like the real thing in the real world. All right, any last question?
And do you think it would be like useful in like a large data set, like skew?
Yes. Yes. Good thought. Very true. All right. I will see you guys Thursday with your ideas, your data sets. Yeah. Yes.